Hi, I just wanted to touch base with everybody and explain the upcoming schedule and how everything's going to work. So, officially, we are not supposed to assign anything or have due dates until April 13th. I can give you a sneak peek into the upcoming material. So, I will be posting new content here very soon on MATLAB. Will actually be using Octave, which you should be able to download for free on your computers. But for anybody who is like working at grocery stores or healthcare facilities that might be on overtime right now, please know that nothing is officially assigned and no work is going to be due until we're officially back up and running on April 13th. So anybody who wants to get started early will be able to do so. Anyone who's not able to get started early, that's completely fine. Know that the semester is now extended a couple of weeks up through May 22nd. So there will be time to get through this material by the end. And if anybody does start early and you get done early, that's great too. So this is going to be kind of an individually paced class from here on out, but I'll be making videos, and please text me screenshots of where you're getting stuck. It really helps if I have a picture of the exact screen that you're on, because sometimes I've got 5 different classes and 4 different subjects, and it's it's easy to get confused of what little area someone's talking about. So if you can just take a picture of your screen of where you're getting stuck, that'll be a big help. For anybody who's gotten behind, please just go through the material in order. So don't jump into anything new that's posted until you've completely wrapped up everything from the first chunk. And that's if you need a video posted or something, again, just send me a screenshot and I can make tons of videos for whatever you would like to see. One of the things, so back here in C++, when you're talking about making algorithms and flowcharts, part of that was starting to think about the project. And this is just a very preliminary 1 paragraph. What idea are you tossing around? And if you're going to start collecting materials to build something, that's fine. You don't have to build something. So some people will do Arduino project, other people it will be purely programming, so you don't have to buy anything if you don't want to. The Arduino sets are kind of fun if you want to go that route. So let me just go ahead and talk a little bit more about that project. And then also for MATLAB, there's some links here for downloading this free software. And there's a lot of resources online. So I will have this up and going shortly here. So there's an install video, and let me know if you're having real trouble getting access to a computer. I know that libraries are closed and there's no more open computer labs, so that might start getting tricky for people. So let me know those problems and I can relay them to our dean. And there's a few resources going around, and we can see what we can do for you in that circumstance. Okay, project info. So going under content, hopefully you're checking your grades and updating anything you might have gotten behind on. So the project really will be in full swing this last chunk. I wanted to kind of get through all of the different programming languages first. And your project can be in Visual Basic and Excel or C++ or MATLAB, or maybe you've learned Python on the side or Java or something and you found a really neat tutorial on some other language. I will let you do your project in whatever programming language you want. The only requirement is that you have written, I'll say, at least 50% of the code yourself. That's great to use open source material, but it needs to be kind of your own work. So whatever you find online, you need to take it and at least modify 50% of it and add something neat that's not, anywhere else on the internet for that. Okay, so your choice of Arduino or even Raspberry Pi project, and there's tons of examples of these types of projects online. So starter kits, and there's kind of the generic version versus the official Arduino boards. I'll show you, this is one of the example sets over here, and it comes with an instruction manual and just some normal parts. So it's a very nice starter kit, but you don't have to buy the official one. The generic ones, the quality isn't, the greatest. So make sure you have a return policy on that, because you may or may not get a working board. That's the drawback for getting a generic. But again, I'm not trying to sell any kits or anything, and you don't have to do this. That's just, one of the things out there. Before you go and buy anything, you can actually get into Tinkercad and do a lot of the programming right there to begin with. So that's kind of a nice thing to know what parts you actually need. And okay, so here we are in Tinkercad. I'm going to just hit this little square, and that will let me switch back and forth between their CAD program and their circuits. If you create a new circuit and just type in something like Arduino. Oh, one thing, I'm using Chrome here. For some reason, some of these buttons are hidden using Internet Explorer, but Chrome seems to work fairly well. So you have the basic board, there's components for it. If you scroll down, there's actually some starter circuits that you can cruise through and kind of experiment with. So I don't know, ultrasonic finder, neopixel, analog, input output. Here's a tone. Yeah, actually a music project might be a fun thing for anybody out there to like create a code that would add harmony or transpose a song or something. There's a lot of neat programs you can make if you're a musician. We'll talk about some of those in the future. Okay, so it has a couple components. Just click on anything and it will tell you kind of what this is. And that's, if you virtually build it online, that will mean that you can order, the little dollar part that you need without getting a bunch of stuff that you don't end up using. So kind of design it online first and then order it and see if you can get it working. Okay, so I'm going to go ahead and start simulation. Wow. Okay. So anyways, that should be kind of fun, and you can get an idea for what Arduinos are without actually buying the package through this. So that should be a neat little thing. Okay, back to project ideas. So this is just under content, and this is the new section that's opened up. It's got the schedule on there. So again, you don't need to create anything or really worry about it until all the way up to May the 4th. So we've got time, but if you're just sitting around at home bored with nothing to do, then might as well get started on it a little bit earlier. So there's the Arduino Tinkercad. If you are just going to write a program, and that is completely fine, maybe the Arduino is going to be a little less of a program and more of getting, little motors to work or LEDs or something, versus if it's purely a program, then that would need to be kind of an impressive program, right? That would show off everything that you've learned through the semester. Some links to help you get started in Arduino if that's what you want, with some example projects, very fun resources here. For making a program or using Arduino, you can do this for either or. So remember that tic-tac-toe game. And I think we kind of got started on that, but not too many people had the computer up and running with, strategies going on. So any kind of a game, checkers, chess, that you could program in where the computer is actually using strategy to play the game, those can get kind of fun. That would count. There's some example, remember that Excel Unusual site? That has some really neat examples of some things that can be done just in Visual Basic on Excel. So, but you would have to take something that's there and really change it. So at least 50% of the program has to be your own coding. You can get started with something someone else has done, but make at least 50% of it your own. Okay, all of your other classes. So maybe you're taking calculus class or physics or something. The MATLAB freeware, that new Octave, it was actually created for chemical engineers. And Mathematica, another big program used for math software, was created by someone trying to solve physics problems. So a lot of programs start out by just trying to solve engineering programs from class. Sorry about that, had to put some dogs outside. Okay, so statics. If you're in statics, you could make a beam calculator, bridge simulation, and dynamics. There's projectile motion. This links over to Colorado University's PhET simulations, which are really neat. Electrical engineering. There's actually a lot of really cool data sets that are online. So you can look at renewable energy production and use and some of the problems the power plants are dealing with, looking at, spikes and stuff. Math, you could look at numerical methods for solving equations and have a program that applies various different methods and chooses the best solution for you, graphs some things out and stuff. And we'll be doing some more math in Octave too. So for all of this stuff, start not by worrying about how hard it is to program, but just finding an idea that matches your interests, that you would be interested in, and know that the programming is probably just maybe half of the work, but half of the work is just finding an idea that you're excited about and interested in and thinking through the algorithm, the pseudocode. So not actual coding, but how are you going to divide up tasks and organize it, and thinking through the flow chart of everything. Chemical engineers, so you can look at chemical reactions, or maybe you'd set up periodic table of elements that you can click on elements and show chemical properties or something. As a bunch of elementary kids and high school kids, everybody's at home, it would be really fun to actually create a program that you sort of donate to the community. And this is another neat opportunity. So if you do consider donating all of your work on this project online, so you post your project in an online forum and you join some of the communities that are out there, that would be considered service learning. And every minute that you put into creating your code is then volunteer work, and you get a certificate. So 15 hours a semester of volunteer work gets an extra little thing on your transcript. It says, oh, you did service learning. And so that's another little thing. You can read about service learning here. And that's something you can add to applications and resumes. And so consider that. So if you make some sort of an educational software like flashcards, or help someone get really fast at addition, going through vocab history, so anything would really work. Make some kind of a interactive educational online learning kind of thing. There's a lot of contests going around too. So I think this links to the Instructables contest, and those can also be really fun to join some of those maker communities online. And just think through all of your hobbies. So if you're a musician, or maybe you enjoy the great outdoors and sports, so you want to make a program that tracks diet and fitness or something, that or strategic, for games, football, baseball, economics. If you want to look at stock market trends and try and get some kind of a handle on what people should be doing there. Or if you like gardening, so everything from plant identification to monitoring your soil and water and light, or maybe just something that's going to tell you what you should be planting, what time of the year, if you're living in this location or that location. If you like to sit down with a good book, maybe you want to make a program to teach people how to do speed reading or vocabulary building. Okay, you can make astronomy programs, cooking, genealogy, if you know, a baseball card collector, a rock collector, you could create some kind of a database to go through and give stats on the collection, and or bird watching, fishing, drawing. Like, you can make your project for anything, and I want it to be fun and something that you already enjoy doing, something that can maybe grow. So you have your initial goals in mind of what it can be, and then something that can keep being added onto and added onto. And this is something that can go in your portfolio. So when you're sitting down to a job interview or putting applications to universities, hopefully this could become something that you'd say, hey, I made this thing, it's online, I have this many users, look at this neat project I was working on. So make something that is expandable and that you're not gonna, you know, regret choosing, that you'll actually enjoy spending a few hours working on it. So again, right now, this is what was posted earlier in that C++, was just propose your idea. So a short paragraph, maybe think through materials list if you're doing something with Arduino. Without Arduino, just find the relevant communities and resources that you can use to get started on this thing. And rather than jumping into code right away, you want to do the pseudocode. So this is just a written outline of how you're going to organize tasks, write the flowchart, the algorithm, think through various different ways to do this and what's going to be the most efficient way to get through your task. So flowchart is going to be extremely important for this, to really think through that. The engineering method, if you haven't had me before, maybe you haven't seen this, everybody's had me, knows this. So whenever you get stuck and you know you're just sitting there with a mind blank and not knowing where to go, you can always get out that engineering method, much better than scientific method. So start by defining a problem. So if I say invent something, come up with an idea, and sometimes it's really hard to come up with an idea, but if you can define a problem, that gets really creative of how you're going to solve that problem. So something to really get creative juices flowing is come up with a really good problem to solve, whether it's traffic jams or food shortages or just internet problem, whatever the problem is, define it and then state your goals, make your goals smart, specific, measurable, achievable, realistic, timely. Background research, the more background research you do, the better your project is going to turn out in the end. So brainstorm more than one solution to that problem, and then analyze and test all of your brainstorm ideas to decide really what the best way to go on, and work with other people. So talk with family members and other people in class, people from community, of what they think about their idea. So the more input you can get from users, the better. And notice in this engineering method, the vast majority of it, you're not actually building anything or doing anything. It's all background until the very end, you finally actually build it and test it and try and commercialize and sell it. And the very last step is, once you have something up and running, it's never perfect, right? There's no perfect car, there's no perfect house or perfect computer program. Anything out there can always be just a little bit better. So how can you make version 2.0? And think about that too. Sometimes you think, oh, I came up with this novel idea, and then you find someone else did it too. You say, oh, darn, I can't do it. It's already been done. Someone else is doing it. Well, you can always make it a little bit better. And that's just how progress happens. So don't be discouraged if you find other people working on the same thing. Be encouraged by that and join the community and get in line and just make what's out there a little bit better. Okay, hope you have some fun with this project. This is, you know, it's not always that you get to sort of define your own path and choose what to work on. And sometimes that can be intimidating because it's easier just to follow directions. I guess there's different personalities. Some personalities very much want to, you know, follow the recipe, and versus others
very much enjoy going out and doing things on their own. But there's a lot of really great websites out there to get you started, and keep in touch. Let me know where you're getting stuck, and I look forward to seeing everybody's ideas. We'll see you later.